All right, thank you so much for joining us today. So in this video, we are going to take the last case and the method of undetermined coefficient. Now we are going to look at an exponential function and trig functions, right? So we said anytime we have non-homogeneous second order and it's involved with the exponential function and a trig function, then what we just need to do is we need to consider this trial solution here, right? So I'll show you how to just memorize this one, or maybe get this one off head, and then the rest here, this one here is just multiplying through by x, right? So let's take example so that you will be able to solve them with confidence. So now let's start here. We'll go through the same process. We know that this is non-homogeneous. So for us to find the general solution, then the general solution is going to be something like this. So general solution is going to be y is equal to the complementary solution plus the particular solution. So that's what we are going to get. And then, as we know, we need to find the complementary solution before we can get the particular solution. So for complementary solution, we pick the left side, or we pick the homogeneous aspect. So we make sure that this is equal to 0, and then we solve it. So the same process again, let's go through. We let y to be equal to this, y prime will be equal to m e to the power mx, and y prime prime will be equal to y prime prime will be equal to m squared emx. Right. So we do substitution here. We are going to have m squared mx plus mx plus emx is equal to 0. So same process, factor this out. It will be left with m squared plus m plus 1 is equal to 0. We are going to set this not to equal to 0. And then if that's the case, m squared plus m plus 1 should be equal to 0. And this is the characteristics equation. So what we just need to do is we need to find the root, right? So I'm going to use the quadratic formula. A is equal to 1, B is equal to 1, and C is equal to 1. So let's do that. M will be equal to minus B plus or minus square root of B squared minus 4AC divided by 2A. So when I do substitution, I'm going to have minus 1 plus or minus square root of 1 squared minus 4 times 1 times 1 divided by 2 times 1. So this is going to give us minus 1 plus or minus square root of 1 minus 4 divided by 2. So guess what? This is going to give us minus 1 plus or minus square root of minus 3 divided by 2. So we know that square root of 3 is still square root of 3, and square root of minus 1 is I. So this is going to give us plus or minus 1 plus or minus I square root of 3 divided by 2. So this implies that m1, we can choose m1 to be, let me say, the negative side or positive side. But since this one is complex, then we just need to write it like m. So m is equal to minus 1 divided by 2 plus or minus I square root of 3 divided by 2. So now this is our solution here. And we know that this is of the form u plus or minus vn I, or iv. So this is what we are going to get. So we can write our complementary solution from here. We are going to have y, which is equal to, we know that this is ux k1 cos vn x plus k2 sine vn x. So we just do substitution for this, and then we are done with the complementary solution. Then we think about so y, which is the complementary solution, is going to give us e to the power minus 1 over 2, because if this is the same as this, then u will be equal to minus 1 divided by 2, and vn will be equal to square root of 3 divided by 2. Right. So this is going to give us k1, and we are going to have cos square root of 3 divided by 2x plus k2 sine square root of 3 divided by 2. So this will be the complementary solution. So now that we are done finding the complementary solution, now we need to think about the non-homogeneous aspect, which is going to help us to find the particular solution. So let me just copy this to the next page. So we know that the question given to us is y prime plus y prime plus y prime plus y is equal to e to the power x sine 2x. Is that right? Good. And then we know that the complementary solution that we had is this. So since the general solution is equal to complementary solution plus particular solution, then we need the particular solution. So for yp, we are going to give a trial solution. But for us to give a trial solution, we need to consider the non-homogeneous aspect, which is e to the power x sine 2x. And this implies that alpha is equal to 1 and beta is equal to what? 2, right? Because we know that when we were learning this one, we saw that was e to the power alpha x sine beta x. So here alpha is 1, that's the coefficient of x, and then beta is the coefficient of x in the bracket here. So now that you've gotten this, then we can write this one as plus or minus beta, right? So this is the same as 1 plus or minus this. So this is what we are going to get. Now let's go and pick our m. What did we get for m? This is what we had for m. So our m, which is u plus or minus iv, was equal to minus 1 over 2 plus or minus I square root of 3 divided by 2. So now what we need to do is we need to compare this to this and see if they are the same or they are not the same, right? So we can see that this is not the same as this, absolutely. So it means that it can help us to write our trial solution. So our trial solution is the same form of this, but here we are using alpha and beta because this is the particular solution instead of using the u and v. So this one, the particular solution will be equal to e to the power alpha x in bracket. So we can use, let me say, different constant. So let me say I'm using a for this, and I'm going to have cos beta x plus, then I'm going to have b sine beta x. So that is how the trial solution is going to be. So the trial solution for this is basically of the same form of this, like the one that we did for the complementary aspect. But here we are changing u to alpha and v to what? Beta. And we are changing a constant too. So basically that's what we were doing here. Then we know that alpha is 1. So yp is equal to e to the power x. Then a cos beta is 2 plus b sine beta is 2. So this is what was our this is what I was trying to say. I was trying to say that now we compare this to the complementary solution, right? And find out if they are the same. So when you can see that even e to the power x and this is e to the power minus f, so there is no way they are going to be the same. So it means that this is what is going to be for the trial solution. Now that we've gotten the trial solution, what we just need to do is the same process. We differentiate and we do substitution here, and then we compare. So it's kind of, this one is kind of very complicated when you are dealing with the differentiation, because it's kind of like it's going to be a lot here. So let's do that. Yp prime is going to be, so I have one function here, I have another function here. So I'll treat it as product rule. So first I will maintain e to the power x and differentiate what is in the square bracket. So when I differentiate cos, I get sine. But I need to differentiate what is inside. I'm going to get 2. I'll get minus sine. So this is going to give us minus 2a sine 2x. Good. Plus, then when I differentiate sine, I get cos. So I'm going to have something like 2b. So this is not beta, this is b. 2b cos 2, no, sine 2x. No, cos 2x, yeah. Good. So this is the first part, plus, then now I maintain this and differentiate e to the power x. But when I differentiate e to the power x, I get the same thing. So I'm going to have e to the power x and then a cos 2x plus b sine 2x, close the bracket. So this is the first derivative. This is the first derivative. So what I need to do is I need to find the second derivative. So you see that this is kind of the differentiation here. You need to pay attention to this. So the same product rule again, I'll maintain this and differentiate what is inside the bracket. So I'm going to have e to the power x in the bracket. When I differentiate sine, I get cos, then I differentiate what is inside the bracket. So this is going to give us minus 4a cos 2x plus, same thing here, differentiate cos, differentiate what is inside. So this is going to give us minus 4b sine 2x. So one part is done, plus now I'll maintain this and differentiate e to the power x. But when I differentiate e to the power x, I get the same thing. So I'm going to have the same thing again, 2a sine 2x plus 2b cos 2x. So I'm done differentiating the first term here. So what I need to do is now I need to differentiate the last term here using the same product rule. So the same again, I'll maintain e to the power x and differentiate what is inside the square bracket. So differentiate cos and get minus sine. So I'm going to have minus 2a sine 2a, then plus differentiate sine and get cos and differentiate this one and get 2. So you're going to have 2b cos 2x. Then plus, now I differentiate, I maintain this and differentiate e to the power x. So this one is kind of like maintaining this and differentiating everything, and I'm going to get the same thing again. I'm going to have a cos 2x plus b sine. So here you need to pay a little bit attention here when you are dealing with the differentiation, right? So the differentiation is what is going to cost us if you get it wrong. So I'm going to substitute them inside this equation. So y prime prime plus y prime plus y. So I need to write y prime prime, but I'm going to simplify it whilst I'm writing it. Good. So let's go through. Multiply it through by e to the power x. So I'm going to have minus 4a cos 2x e to the power x minus 4b sine 2x e to the power x minus 2a sine 2x e to the power x, then plus 2b cos 2x e to the power x. So this is what basically I'm doing. I just multiply this through by this, which is giving me this, and then also multiply through by e, this, and also giving me this. So I'm here, I'm going to multiply this one by e to the power x. So this is going to give us minus 2a sine 2x e to the power x, then plus 2b cos 2x e to the power x. So I'm done with this one too. Last one I need to do for this. So plus a cos 2x e to the power x plus. So here you need to pay attention here with your multiplication and with your the differentiation, because if you get one of them wrong, it means that you are going to get it wrong. So basically, this is not difficult. The only way to get everything right here is to practice more examples, and then you'll be done. So that is y prime prime. We need to add y prime. So this is y prime. I will simplify it whilst I'm writing it. So I'm going to multiply this one by e. So I'm going to have minus 2 a sine 2x e to the power x. Then I'll go to plus 2b cos 2x ex. So I'm done multiplying this one by this. Then I'll multiply this e here through this and that. So when I do that, I'm going to have plus a cos 2x ex plus b sine 2x ex. And then lastly, I'll multiply or I'll add plus y. So y is this. So I'm going to multiply through by e through. So I'm going to have plus a cos 2x ex plus b sine 2x ex. And this one should be equal to e to the power x. E to the power x is this sine or cos? Sine 2x. Good. So this is a whole lot of work. Now, the only interesting part here is now we can do some cancellation here, right? So that the equation becomes very small. So that is basically what we need. So we need another page that we can use. So now let's do the cancellation and move the next. Now let's look at those with this. Let's see if we can cancel. This is kind of a whole lot, but I'm sure we can cancel a bunch of them out and see what is going to be left. So let's look at the one with the black. Let's see if we can see something like a cos 2x. So we are going with cos. Okay, we have cos here, but this is b. No. We have cos here. No. Now this and that is, I think, the same, right? Yes, because we have a cos and then e, right? And then we look for another cos with a. Another cos is also here. This one too is cos, the same thing. We have another cos which is going with the a again here. So we have them here. Is that right? Good. Do we have another cos with a? Let's see if we have another cos with a. Okay, no. So now this is positive, this is positive, this is positive, and this is positive. So giving us 1, 2, 3, and this is 4. So it will be left with minus a cos 2x e to the power x. So we are done with that one. Now let's look for a term that has this. That has b sine. So b and sine, b and sine, b and sine, no. Okay, we have b and sine here. We have b and sine here. Look for another one with b and sine. Okay, we have another b and sine here. Another b and sine also here. So let's compare them again. This is 1, 2, 3. They are positive, and this is minus. So it's also going to give us minus b sine 2x e to the power x. So it's kind of, you need to pay attention to this. So now let's look for the one that has let me say, this, right? So now let's go through this. We want the one that has a and sine. Okay, so I can see one here, a and sine also here, another a and sine also here. We have another one again, no. So the one with the blue, this is 2, this is also 2, this is also 2, but they are all minus, minus, minus. So this is going to give us minus 6. So minus 6a sine 2x e to the power x. Now let's go for the one with 2b cos. So I have cos also here, and then I have another cos here. So I think that's the last term. So the one with the red, this is positive, positive, positive. So we are going to have plus 2b cos 2x e to the power x, which is equal to the e to the power x sine e. Good. Now, so this is the simplification now. Now let's try and group like terms, right? So we have terms with cos, we have terms with sine, right? So this is sine, and this is cos, and this is cos. So let me start with the cos. This one cos 2x is here, and e, they are all here. So when I factor this out, it will be left with this and that. So I'm going to have 2b minus a times cos 2ex, right? So when I factor this and this out, it will be left with minus a and 2b. Good. Then plus the one with the sine, which is this and that. When I factor sine and ex out, I'm going to have minus b minus 6a sine 2 this ex, and this will be equal to e to the power sine 2x. So I just combine this and that, which is here, and I combine this and that, which is also here, and is equal to this. Now let's compare terms. We can see e to the power x and sine 2 here, and I can also see the same thing here. So the one with the red are the same. So if they are the same, then we can compare the coefficients. So the coefficient of this is 1, and the coefficient of this is this. So it means that minus b minus 6a is equal to 1, right? But now let's compare this one here. We don't have any term that on the right which is going with this. So we are assuming that it's equal to 0. So it means that the coefficient of this should be equal to 0. So we are going to have 2b minus a is equal to 0. So what we just need to do is we need to solve this one simultaneously to get a and b, then we are done. So from this one, we are going to have a to be equal to 2b. And then we can plug this one inside this, and then we are going to have our b or a. So minus b minus 6 times 2b is equal to 1. And then we are going to have minus b minus 12b is equal to this. And then minus 13b is equal to 1, and b will be equal to 1 over minus 1 over 13. Minus 1 over 13. So we have gotten minus 1 over 13. So now let's try and see if we can get something like, a, right? Let's see if we can get something like a. Let's see if we can get something like a. But let me see something here. I think I made a mistake somewhere. One of the terms supposed to be 6. I think this one's supposed to be 6. Let me check. The b, this one was 2, 2, 2 here, 2 here, and 2 here. So this one's supposed to be 6. Apologies. This one's supposed to be 6. So this one is going to be 6. So please, when you are doing it, pay attention, because a small mistake changes everything. So this one should be 6. Good. So this one instead of 2 will be 6. And then I plug it inside. So this one will be 6. And 6 times 6 will be 36. And this is going to give us minus 37. So this one should be 37. Good. Then I'm going to plug this one inside this to have a. So when I do that, my a will be equal to 6 times minus 1 over 37. And this is going to be minus 6 divided by 37. Good. So now I've gotten a, I've gotten b. So let me go and substitute this inside my solution and see what we are going to get. So this was the solution that we guessed. We guessed this solution. Where is it? We guessed this solution. That's a particular solution. So we need to put in our a and b. So let's see what we get from here. So when I paste this one here, which is a particular solution, yp will be equal to e to the power x. A is minus 6 over 37 cos 2x, and then b is minus 1 over 37 sine 2x. So the general solution, which we know to be complementary solution plus particular solution, is going to be, so what was the solution for this? We had this one here. So I can copy it here and then add it to So this is the complementary solution. So complementary solution plus particular solution. So this is my particular solution here. I add it and then I'm done. So this will be the general solution. So it's kind of very complicated when you are dealing with this. And when you have the sine and the cos, the differentiation becomes plenty, right? So now let's take another one, which we are going to assume another different trial solution. So we have 4 questions before I'll give you the trial question to go through for me. So stay here. So the same process again. This one, for general solution, so we go through the same process for general solution. For general solution, y is equal to yc plus yp, right? And then we need yc first. So we are going to assume that y prime prime plus y is equal to cos 2x. Now we've done this for like several times, so I can write this one straight like m squared e to the power mx plus e to the power mx, right? I hope you agree with me. So this one should be 0. So here y is equal to e to the power mx, y prime. So the more you do it, you have them off mind. So you can just skip this one, writing this, and then you just take it from there. And this one was m squared that. Then you do substitution. You plug this one inside this. So we've done it for several times. So I'll factor this out and it will be left with m squared plus 1, which is equal to 0. And this is going to give me something like this is not equal to 0. So it means that m squared plus 1 should be equal to 0. M squared is equal to minus 1. And I'll take the square roots on both sides. And m will be equal to plus or minus 1. Sorry, plus or minus I. And this is the same as 0 plus or minus I. So which is of the same as u plus or minus iv. So u is 0 and v is 1. Good. Good. So this one will help us to write the complementary solution to be, we know that is ux. I always love writing the formula before so that I always have it in mind. So I write this and then do substitution. So this one is 0, k1 cos vn x plus k2 sine. Okay, vn is 1, so this one will be just x. This one will be x. E to the power 0 is just 1, so it will be left with this cos s plus k2 sin x. So now that we are done with the complementary solution, let's go ahead and find um, the particular solution. So we know that y prime prime plus y is equal to cos 2, right? And then we have our complementary solution here. Now what we need to do is we need to take the non-homogeneous aspect. So cos 2x. Remember this one should be of the form e alpha x cos beta x when it is with cos. When it is sine, it goes with sine. And here with this one, we don't have e, so we can assume that this is like e to the power 0, right? So here we can assume that alpha is 0 and beta is equal to 2. So this is how we are going to get our alpha and beta. So with that, this one will help us to guess our particular solution. So we are going to get something like yp is equal to e to the power alpha x and then a cos beta x plus b sine beta x. So let's do substitution and see what we get. Alpha is 0, right? So this one will just go away. So we have e to the power 0, a cos, and then b sine 2x. So this one will go away. So we are going to have something like this. Our yp will be equal to a cos 2x plus b sine 2x. Good. Now let's compare this to our complementary solution. So let me write let me send the complementary solution to the other side so that we can, or let me add the general solution to it, the original equation to it. So let's send them here. So we have them here, right? So let me bring this one down and then push them up. Good. So we have the complementary solution, and this was the original question. So we want to compare the particular solution to this and find out if they are not the same. So we see that they are all constant times cos, constant times sine, but the angles are not the same. So it means that they are not the same. So it means that this is going to be our trial solution. So we can go ahead and differentiate. So yp prime will be equal to, when I differentiate this, I'm going to have minus 2a sine 2x plus, when I differentiate this, I get 2b cos 2a. So I hope you understood it. Differentiate sine, get sine minus sine, and differentiate 2x and get 2. The same thing for this one too. Let me differentiate again, and I'm going to have minus 4a cos 2a minus 4. So if you know how to do differentiation, you can see that sine and cos, they just alternate. When you differentiate this, you get this. When you differentiate this, you get this. So now that we are done with the differentiation, plug in this and this inside this equation. So let's do that. We are going to have minus 4a cos 2x minus 4 sine 2x plus y is a cos 2x plus b sine 2x, which is equal to cos 2x. Good. Which is equal to cos 2x. So it means that now let's try and group cos and sine together. So with the cos and then the cos, I'm going to have minus 4a. Oh, they are all the same term because this is minus 4a and this is a. So this is going to give us minus 3a cos 2x. Good. And then this is minus 4b and this is positive 1b. So this is going to give us minus 3b sine 2x, which is equal to cos 2x. So let's group like terms. We have cos on the right and we have cos on the left. So the coefficient of this is 1. The coefficient of this is minus 3. So this is going to give us minus 3a is equal to 1. And this implies that a is equal to minus 1 divided by 3. Then we don't have any term here with sine, so it means that the coefficient of sine here should be 0. So minus 3b will be equal to 0, and this implies that b is equal to 0. Very simple, right? So now let's plug it inside the particular solution. So what did we get for the particular solution? We had the particular solution to be this. So a is minus 1 over 3 cos 2x, which is a here, but b is 0, so this one will go to 0. So this will be the particular solution. So our general solution is going to be the complementary solution, which is this, plus the particular solution. So we are going to have k1 cos 2x plus k2 sine 2x minus 3 cos 2x, which is the same as the, oh, this one's supposed to be just x, not 2x. Good. So this is the general solution for the function. Good. So this is the general solution for the function. We have 2 more questions. I think this one too has different form. So let's figure it out. The same process. I'll just go through this very quick. So I'll just start by going through the process. So for yc, y prime prime plus 9y should be equal to 0, right? And then we go through the same process. So we know that this one should give us this one should give us m squared e to the power m plus y is e to the power mx, which is equal to 0. As we know that this is equal to mx, y prime is mex, and y prime prime is equal to m squared e mx. So plug them inside this and then you are done. Factor this out, m squared plus 9 is equal to 0. Then e to the power mx is never 0. It means that m squared plus 9 is equal to 0. And we are going to have this one as m squared is equal to minus 9. And then m squared, square root of m squared is equal to square root of minus 9. And this is equal to plus or minus 3i, which is of the form 0 plus or minus 3i, u plus or minus vin I. So let's write a complementary solution. So if you have noticed something, with the last row, we always need to have this one to be in the complex, right? If it is not complex, then it's never the last row. So we should be having this in mind. So ux k1 cos 2 cos vin x plus k2 sine vin x. So this is going to give us u is 0. So k1 3x cos vin is 3 and k2 sine 3x. This is going to give us 1, right? So we are going to have k1 cos 3x plus k2 sine 3x. Good. So this is what you are going to get for the complementary solution. Let's try and figure out the particular solution. It's very important here. So here we know that the original equation given to us is y prime prime, the original y prime prime plus 9y, which is equal to sine 3x. So sine 3x. So let's guess the general particular solution. So yp, as we guess, we know that from this, from here, it's of the form e to the power 0 sine 3x, which we compare to alpha x sine 3x sine beta x. So here alpha is 0 and beta is equal to what? 3. Good. When we compare. So writing the particular solution, which is going to give us something like e to the power alpha x a cos beta x plus b sine beta x. When we do the substitution, we are going to have something like e to the power 0 a cos 3x because beta is 3 and b sine 3x. So it means that the trial solution that we are looking at right now is going to be a cos 3x plus b sine 3x. But anytime we consider a trial solution, we need to compare the trial solution to the complementary solution to check if none of them are the same before we can conclude on differentiating and putting it inside the function. So let me just copy this one to the next page so that we can do the comparison. So now I paste this one here, and then let me go and bring my particular solution and copy my particular solution and also paste it here. Let me just move this one, the question, to this side, and now I have my particular solution and complementary solution. So let's compare. We have, look at this, we have, they are the same because this is cos 3x, the same thing here with a constant, and then sine 2 also here, and also here with a constant and with a constant. So it means that this can't be the trial solution. We need to modify it by multiplying through by x. So it means that our trial solution should be multiplying through by x. So we have ax cos 3x plus bx sine 3x. So that now we can differentiate them. So we can see that now, because we have x here and there's no x here, x here and there's no x here, now we can consider this one as a trial solution. So now let's go through the process by differentiating. So yp prime, this one is going to be a product rule. So when I maintain a, now when I differentiate x, I get 1, so it will be left with cos 3x plus, now I'll maintain x and differentiate this. When I differentiate cos, I get minus sine, and I differentiate this, I get 3. So this is going to be minus 3s sine 3x. I hope you had what I did. So I'm maintaining x, which is here, and then I'm differentiating what is inside the bracket. I'm getting 3, and then when I differentiate cos, I get minus sine. So same thing for the b, maintain the b outside, differentiate x, and it will be left with 2x. Then now differentiate sine, and you're going to have 3x cos 3x. So this is the first derivative, right? So we need to assume y prime prime 2 to be now the same product rule again, but this one there is no x, so I maintain this one and differentiate this. This is going to give me minus 3 sine 3x, agreed? Then minus, now I need to differentiate this again, right? So I'm going to have, when I maintain sine 3x and I differentiate x, I'm going to have um, 3 sine 3x, then plus, now I maintain 3x and differentiate sine, I'm going to have 9x cos 3x. Good. So that's the first differentiation. So I maintain the minus out because the minus will multiply through. So here I maintain this guy here and differentiated 3x and I had 3. Then here I maintain 3x, but when I differentiate 3x, I'll get 3. So 3 times 3 is 9x, and I differentiate sine and I get cos. So now let's get to the last term here. The last term there is going to be plus b. When I differentiate sine, I'm going to have, this one should be 3. I'm going to have 3 cos 3x, then plus, I do the same product rule here. I will maintain cos 3x and differentiate 3x. So I'm going to have 3 cos 3x plus, now this will be 9 minus 9 sine 3x. Good. So this is y prime prime. This is y prime prime. So now substitute y prime prime and y inside the original equation, and let's see. So whilst I'm doing the substitution, I'll simplify, right? So I'm going to have, simplifying this by multiplying through by a, I'm going to have minus 3a sine 3x. Then I'll multiply a through this by multiplying through by minus 2. So I'm going to have minus 3a sine 3x minus 9ax cos 3x. Then I'm here, multiply through by b, you have 3b cos 3x plus 3b cos another 3x. Could have added this, but okay. 3bx sine 3x. So this is y prime prime. Now let's look at plus 9 of this. So I'm going to multiply 9 by this, and I'm going to have plus 9a x cos 3x plus 9b x sine 3x, and this should be equal to sine 3x. Everything here should be equal to sine 3x. Good. So now that you're able to go through the differentiation, let's try and see if we can cancel some of the term. So let's look for a term with a and sine. We have another a and sine here. We have another a and sine. No. Good. So we don't have another a and sine. So when I combine this one, I'm going to have minus 6a sine 3a. Now let's look for a term that has ax cos, as cos. So we don't have as cos, as, okay, we have as cos here. So fortunately for us, this will cancel this because this is minus and this is positive. Good. Then now let's look for another one which goes with 3 or b cos. So we have another b cos here. Okay, good. So this one will be plus 6b cos 3x here. Then the last term is this guy, and they're going to cancel out, right? Because 9 positive and minus, and this one should be equal to 3 sine this. So let's compare. We have sine here, this one should be x, and then we have sine here. So the coefficient of this is 1 and the coefficient of this is this. So this is minus a is equal to 1, and a will be equal to minus 1 over 6. And then we don't have cos on the other side, so 6b will be equal to 0 and b will be 0. Indeed. So our particular solution will be equal to, so what is this? Here, b is 0, so this one will go to 0, so it will be left with this one. So we are going to have minus 1 over 6s cos 3x. Is that right? Good. So now, finally, we write the general solution. So our general solution will be the complementary solution, which is k1 cos 3x plus k2 sine 3x minus the particular solution. So we add that particular solution. So this is the general solution that we are going to have. This is the general solution that we are going to have. So they are very simple. It's just when you are doing it, you need to take your time and then just do them step by step so that you don't get it wrong. Right? Let's do this last question, and then I'll give you a trial question for you to do. All right, so let's go through the same process again. So for complementary solution, y prime prime minus 2y prime plus y is equal to 0. Let's pick y to be equal to e to the power mx, y prime m, this, y prime prime is going to be m squared mx. Do the substitution, m squared mx plus minus 2m e to the power mx plus e mx is equal to 0. Factor e to the power mx out, and what will be left? It will be left with m squared minus 2m plus 1 is equal to 0. And then we are going to have m squared minus 2m plus 1 is equal to 0. So this is 3. So let's use the quadratic. A is 1, b is minus 2, and c is 1. Good. So our m will be equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. Is that right? We know b to be minus 2, so minus minus plus or minus square root of minus 2 squared, and then plus, no, minus 4, 1 times 1 divided by 2 times 1. Good. So this is going to give us 4 plus or minus square root of 4 minus 4 divided by 2. So this is going to be 4 plus or minus 0 divided by 2, and this is going to give us something like 4. So this is going to give us something like, okay, this is going to give us 4 divided by 2, and this is going to give us 2. So we can see that this is a double root, right? Like we have m1 to be 2 and m2 to be 2. So is that true that when I form 2, 2, I'm going to get this? Let me just check it. So x minus 2, I think this is not true, because if I have m minus 2 times m minus 2, then this is not true. Let me check my solution again. So a is 1, this is minus 2, and this is 1. Good. So I'm going to have this and this. Yes, this one is going to be 0. Okay, good. So I saw the mistake. This guy should be 2. This guy should be 2. So this one will be 2, and this one is going to be 1. Good. Good. So you will see that the one that we just solved, I just brought it. You will see that when we solved it, we didn't have anything like um, complex, right? Nothing is complex here. So we are going to have something like yc. Since this is double root, we are going to have something like this. C1 e to the power m1 plus C2 x e to the power m1x. So this, our complementary solution will be C1e x plus C2x e to the power x. So don't be confused when you are solving this one and you are not getting the final answer to be complex. So now let's see how we can get the particular solution from this when we have this such a question. So let me paste it here. So this is our complementary solution, and the question given to us is y prime prime minus y prime minus 2y prime plus y prime is equal to e to the power x cos s. So now here we are going to consider the solution. This is of the form e to the power x alpha x cos beta x. So alpha is 1 and beta is also 1. So this is kind of, we have alpha plus or minus beta I, which is 1 plus or minus I. So we are going to consider a trial solution, yp. So since the other side is a trig function, we are going to consider something like this. Yp is e to the power alpha x a cos this plus b sine beta x. So this is going to give us alpha is 1, so we are going to have x a cos this one too is 1, so we are going to have something like x plus b sine x multiplied through by e. And we can see that when I compare this to this, since this one has no cos and sine, they are not the same. So all I need to do is I need to differentiate this and put it inside this and find my particular solution, and I'm done. Right. So when you are dealing with differential equation, expect different questions. That's why you need to solve examples so that you don't get confused, right? Oh, why is it that this one I didn't get complex? So how am I going to compare this to my particular solution? Doesn't matter, right? All you need is, now since this one not the same as this, then you go through the same process again. So let's do that. Yp prime is going to be, I maintain ex and I differentiate what is inside the bracket. So I'm going to have minus a sine x plus b cos s. Then plus, now I maintain this and differentiate this. So I'm going to have plus ex, because when I differentiate, that's what I'm going to get. Then a cos s plus b sine x. Then I need y prime prime. The same thing again, product rule here. I maintain ex, then I differentiate what is inside the bracket, which is going to be cos s minus b sine x. Then now I maintain what is inside the bracket and differentiate this. So I'm going to have the same thing again, then minus a sine x plus b cos s. Right, then I look at this one, then I differentiate, product rule again, e to the power x a cos x, no, minus a sine x plus b cos s. Then now I maintain what is inside the square bracket and differentiate this. I'm going to get the same thing again. A cos s plus b sine x. So this will be the product rule. So we just need to sub them and then we are done. So let's plug them inside this. So y prime prime, I'll write it by simplifying this here. So I'm going to have e to the power minus a cos s minus a e to the power x cos s minus b e to the power x sine x plus or minus a e to the power x sine x plus b e to the power x cos x. So multiply this one by this, get this one, multiply this one by this and get this one. So I'm here. So now when I do that, I'm going to have another one minus a e to the power x sine x plus b e to the power x cos x. So finally I'm here. Then I'm going to have plus aex cos x plus bex sine x. Then minus 2 times y prime. So I'm going to multiply this one by 2 and I'm going to multiply this one to true, right? So I'm just multiplying this one by minus 2 and multiply it through straight away. So I'm going to have, so when I multiply this one by this and by minus 2, this one will be plus 2a e to the power x sine x, then minus 2b e to the power x cos s. Good. Then I'm done with this one. I move here and here. So this one will be minus 2a e to the power x cos x, another minus 2b e to the power x sine x. And this one should be equal to, no, then we need to add plus y. This is y, so I'll multiply it. So I'll have plus e x cos x. Is that right? Okay. Oh, there is a cos. So this one is going to be aex cos x plus bex sine x. And the whole of this should be equal to e to the power x cos s. Amazing. So this is what we are going to get. So what are we going to do here? Now let's try and cancel. So you see the way we do the cancellation. When we are solving it, the same thing. Pick the first term and go through and see if I can see the same term in. So e and cos and a. So a and cos, a and cos, a and cos, a and cos, a and okay. So we have another a and cos here, right? We have a and cos again. Okay, we have a and cos again here, and then another a and cos. Okay, another a and cos is also here. So let's try and combine them. So 1, 2, 3, 4, right? This is positive, this is positive. This is 2. So this and this and this will cancel and it will be left with this. We have another a and cos again. Let me see if that's true. A and cos again. No. So this will cancel this and this, so it will be left with this. So you're going to have minus ae cos x. Then let's look for this term, b and sine, b and sine, b and sine, b and sine, b and sine. Okay, we have b and sine here. So I'll underline that. B and sine, b and sine. We have another b and sine here. and I think we have another bn sign here. So let's combine them. The one with the red, this is minus, this and this will be 0, and it will be left with this, because this is positive, positive, cancel this out, and it will be left with this one. So we are going to have minus bex sine x. Let's go another one for a and sine. A and sine, another a and sine is here. So we have 4 of them. We were using the same thing, so we didn't see it well. So let's use blue. A and sine, a and sine, a and sine. So this and this and this will cancel. Good. So now let's go for the b and cos, b and cos, b and cos, and b and cos. This and this and this will cancel. So everything is out, and this one should be equal to e to the power cos s. So now e cos, right? So the coefficient of this is 1 and coefficient of this is minus b. So you are going to have minus b is equal to 1. This implies that b is equal to minus 1. Now e and cos again. Oops. This was not cos. So e and cos rather here. So minus a rather, which is equal to 1. This implies that a is equal to 1, and then minus b is equal to 0. So b should be 0 because we don't have anything with e and sine at the other side here. So it means that now finally we write our particular solution, which is going to be from here, b is 0, so this one will go to 0, and a is minus 1. So we are going to have minus e to the power x cos x, right? And then our complementary solution was equal to c1 e to the power x cos x plus, no, there's no cos, plus c1 or c2 x e to the power x. I think so. Good. So finally, our particular solution is, our general solution will be equal to c1 e to the power x plus c2 x ex, and then minus e to the power x cos x. So if I want to do something small, since this one is our last solution, then I can write this one as, I'll factor ex out, and I'll have this c2x minus cos s. And this is going to give us our general solution. So we've gone through all the 4 methods. The first method with exponential function, the second method with polynomial function, the third method with polynomial and exponential function, and then the fourth method with, let me say, polynomial functions, no, exponential functions and trig functions. So we are done, and all the method that we are using, the guess that we are doing, and then when we guess it, what we do, we differentiate and we put it inside. The method that we are using, it, we call it method of undetermined coefficient. So everything that we've done throughout method 1 and method 2, we're using method of undetermined coefficient. So if the question just states that find a general solution using the method of undetermined coefficient, don't just get confused. It's the same process. Go through the same process and get your answer done. So in the next video, we are going to talk about method of variation of parameters. So let's assume that they've given you this general solution here, and the question is asking you to use method of variation of parameters. Then you cannot go through the methods that we did. How to use the variation of parameters has its own way of guessing the particular solution. So in the next video, I'm going to assist you with method of variation of parameters. So see you in the next video, and don't forget to drop your final results in the comment section.